So here now we'll be entering calculus. I think we are able to tell ourselves what calculus entails. Um, mind you, no man, I'm not mixing it up. I'm not one man, so we're talking about calculus today. So calculus entails a lot, as we all know, but hopefully we can cover. Hope we're able to cover the power rule today. So generally, calculus is, let's say this is a function f of x is equal to 2x squared minus 3x. This is a function, right? So calculus involves differentiating this function, if not because of time, and moreover, the exam is fast approaching. I would have explained everything from the basic concept of calculus, where did it come from, and the likes. It was developed by Newton and Leibniz. Newton developed differentiation while Leibniz worked on integration. So if f of x is equal to 2x squared minus 3x, then differentiating f of x means finding f prime of x. Look at it very well. We are looking for f prime of x. That means you are differentiating f of x. In some cases, you will not be given the function as f of x. You will be given as y, as we all know, right? You can write it as 2x squared minus 3x. It's 2x squared minus 3x. Differentiating y means you're having the y dx. Means you're having the y dx. In this class, we've treated the differentiation from the first principle very well. I would like not to go back to it today. Actually, I want to go back to it. The first reason is that there are few questions that will come from differentiation using the first principle. Because it's just working. You're going to arrive at the same answer with the one you get using the power rule. So I'm going for the power rule first. I'm given the function f of x now. It is equal to this. Then find f prime of x, which is going to be the same as the y dx. So I can say it is f prime of x if it is presented in this form. And as well, I can say it is the y dx if it is presented in this form. That is differentiating y with respect to x. Differentiating y with respect to x. So using the power rule, if y equals ax raised to power n, then the y dx is going to be equal to this a times n, that is an x raised to power n minus 1. So guys, let's move with y equals 2x squared. Now look at it very well. Y equals 2x squared. Differentiating this now, let me use 2x cubed to show it very well. I'm multiplying these 2 by the 3 here. So bring it here. That is 2 times 3, right? So I have 6. X raised to power 3 minus 1. The 3, just so I am having 2 times 3 is 6x squared. So I've differentiated y with respect to x. If you have any question, let me know. So I've differentiated y with respect to x. If I had f of x equals 2x squared minus 3x now, differentiating f of x, which is f prime of x, is going to be equal to 2 times 2, that is 4. Then the x that is there, raised to power 2 minus 1, that is 1. So that is 4x. Minus, this is 3x raised to power 1, right? 3 times 1, that is 3. 3, x raised to power 1 minus 1, that is 0. So anything raised to power 0 is 1. So Please mute your mic. Please mute your mic. So let's say I have a complex function now differentiating a polynomial. The polynomial has a y equals. Please mute your mic. Who's it? Olavi, please mute your mic. 5x raised to the power 5 minus 4x raised to the power 4. This one. 5x raised to the power 5 minus 4x raised to the power 4 plus 9x cubed minus 2x. So differentiating this now with respect to x means we're finding dy dx. So we say dy dx is equal to this 5 multiplied by the 5 here. That is what? 5 times 5 is 25. Let me change this one to 6. So this is 25 x raised to power 5 minus 1. So that's 4. 25 x raised to power 4 minus 6x raised to power 4. That is, take the 4 multiplied by 6. 24 x raised to power 4 minus 1. 3 plus 9x cubed. The 3 now multiplied by 9. 27 x raised to power 3 minus 1. 2 minus 2x squared. The 2 multiplied by this 2. That is 4x raised to power 2 minus 1. That is another one. Plus all constants in calculus gives 0. Because the x is raised to the power of 0. So 0 minus 1 is still okay. 0. How do we even do something like this? Yes, it is raised to the power of 0. I'm just please wait. It is equal to 0, but wait. Why it's raised to the power of 0? Yes. So 0. Look, I couldn't even do it. See, so this is the solution to this. So let's say we have another one here. Oh, no. So let's say we have y equals 9x squared plus 2x minus x cubed. Differentiating this as well is just like this. dy dx is equal to 9 times 2, that is 18 x raised to power 2 minus 1, that is 1. So 18x plus 2, just remove the x in this case, just remove the x straight away. Minus x cubed is going to 3 times this. That's 3 x raised to power 3 minus 1, 2. So the derivative of this function, this is the function. So this is the function. And this is the derivative. So the function is also known as the antiderivative. So this is the derivative, all we got when differentiating. So we had 18x minus 3x squared plus 2 as the derivative. So please, did you understand what you've done?
Don't understand, please. I understand well.
Please, if you didn't understand, listen again. Y equals 5x raised to power 5 minus 6x raised to power 4 plus 9x cubed minus 2x squared plus 4. That is the function given. It's a polynomial function. To differentiate it, we're going to take the power. Easy to multiply the coefficients of the value we are differentiating with respect to. That is 5 multiplied by this 5. That gives 25. And the x is raised to power 5. Now remove 1 from the power. So 4. 5 minus 1, that is minus, look at this again. 4 times 6, that is 24. X raised to power 4 here now, minus 1, that is 3. Plus 3 times 9, that is 27. You multiply the coefficient of the variable you are differentiating with respect to by the power. So the power is 3, the coefficient is 9. 3 times 9 gives 27. X is a variable. Raised to power 3 minus 1, that is 2. Please understand it that way. And if this is 2x squared, multiply the power which is 2 by the coefficient which is 2. That gives 4. X raised to power 2 minus 1, that is 1. So 4x raised to power 1 is the same as 4x. That is what is happening over here. And the differentiation of a constant will always give 0. The derivative of a constant is 0. The derivative of a constant is 0. That doesn't have any variable with it before. So it's going to be 0. Yeah, remember it is 0. Remember how it is 0. So that is what we did. Did you understand now? Or do you understand it now? This IJ Tech was the one that said he didn't understand. Do you understand it now? Or shall we explain it? Should we take another example?
Let's take another example.
Lonan, what do you have to say? Lonan, you're raising your hand.
Yeah. So anytime you differentiate the constant that doesn't have
Okay, originally this is the constant. Be the x of the constant 0. It can be anything. It can be c, it can be 4, it can be 9. So far it is not having the sign x. So we know that x is not here. So we can put a false x and say it is raised to the power of 0. In indices, the fourth law of indices is the 0 index. And that gives 1. So we can say it is still 4 times 1. So 4 times x raised to power 0. So you use the constant, the power to multiply the coefficients, right? That is 0 times this 4, x raised to power 0 minus 1. And even before even simplifying everything, 0 times all this one made 0. So that is why the function of a constant, when differentiated, will give you 0. The derivative of a constant is always 0. That is the reason over there. 0 times everything here. This is 0. 0 times 4x raised to power minus 1. 0. Because it is 0 that is the power of this x. If you didn't know where the x comes from, it is because of one law in indices. We call it the 0 index. This is 4, right? We can say 4 is 4 times 1. So I want is 1. X raised to power 0 can be 1. According to 0 index, anything raised to the power of 0 gives 1. So that is why it is 0. So now multiply the coefficient by the power. So multiplying 4 by 0 renders everything 0. Don't solve any other thing. 0 times 4, 0. So 0 times anything you will be encountering there will give you 0. That's how it is. So let's take more example on differentiating functions. F of x is given to be 2x squared minus 9x plus 7x cubed. Or let's say 2x cubed minus 9x squared plus 7x minus 16. Find f prime of x when x equals 2. Everyone, look at what we are doing. I'm using this opportunity to explain this to you, and at the same time using it to further. We're going further. So please listen. F of x is given. We now said find f of x. Find the value of f of x. After getting f of x, impute 2 for x and then get the value of f of x. So let's go together, everyone. F prime of x instead of f prime of x. f prime of x is going to be 3 times these two. That is the power multiplied by the coefficient. That is 6 x raised to power 3 minus 1. That is 2. Plus 9 is the coefficient to power. So 2 times 9 gives 18. Then x raised to power 2 minus 1, that is another x raised to power 1. Plus 7x becomes 7. So minus 16 becomes 0. So that is cancelled out. Am I making sense? IJTech. You can just let me see.
Why did you remove the because this says that 7x minus
7x, I differentiated it now. That is 7 times the power of x. This is 7x raised to power 1. So multiply 7 by the power. That is 1 times 7. That gives me 7. X raised to power, the power minus 1. That is 1 minus 1. So that is 7x raised to power 0. And we said in the laws of indices, anything raised to power 0 gives 1. So we have 7 times 1, which is the same as 7. That is how 7 is gotten. And the derivative of a constant is 0. So we don't have to put it there again. So this is the derivative of this function. Then when x is equal to 2, then we're going to have 6 times 2 squared. That is 6x squared. 6 times 2 squared plus 18 times 2 plus 7. That's going to give us 24 plus 36 plus 7. And therefore, f prime of x gives 67. Any questions? Any question from anyone? Everyone, did you understand it?
Yes.
So you might be given f of x and you'll be asked to find the value of f prime of x when you are given the value of x. So this is how it is. We are still dealing with the power rule, and this is the simplest rule of calculus. We are just taking the power using the form y equals ax raised to power n. So that is what we are still doing. We still have a lot to do. So now after that, let's take the laws now. Let us look at standard integrals. Standard integrals before taking the rules of calculus. Standard integrals. When y equals x squared, is there anyone that can just use his or her mouth to tell me the y dx now? When y equals x squared, y dx is what? Unmute your mic and say it.
2x.
That is it. Thank you very much. So, and then if y equals 7x cubed, y dx is what?
21x.
So IJFL, do you see? What you need is just to practice it. You can see they are doing it with brain. Now let me show you one of them over here. Okay. So when y equals 7x cubed minus 2x squared plus 4x, is there anyone that can tell me the y dx straight away? Perfect. So IJT, I'm only using this to tell you, to show you that you can definitely understand it very well too, by constant practice. So you can see how, and they both gave the correct answer. I believe in you, and I wish you the best. So that's that as far this. So we'll be talking about the functions, integrals. Exam is fast approaching. Because of that, I might not be showing you the basic derivatives or the basic derivation of all these formulas. But mind you, I will show you the standard integral. When y equals sine x, as a smart person, you can just put it somewhere in your notebook. When y equals sine x, then dy dx is equal to integral. I wrote integral, derivative, sorry. You can draw this table and draw it. Now, when y is equal to sine x, okay? Anyone from here, the y dx is what?
Cos x.
Thank you very much. So the y dx is cos x. That means if you have a function that says 2x squared plus sine x, that is y. So, Miss Joy, I would like you to do this for me. Differentiate it. 4x plus cos x. Thank you very much. So because you differentiated 2x squared to be 4x, and you differentiated sine x to give you cos x. So straight away, you have 4x squared plus cos x. Using the first principle, we can show that the derivative of sine x is cos x. Actually. But because of time, I won't be doing all that here. I'm just giving you the standard derivatives. So when y equals to sine x, then dy dx is cos x. You can see we differentiated this to 4x and differentiated this to cos x. Please, did we all get that concept? That is the meaning of standard derivative in this point. So when y is sine x, dy dx is cos x. I can show you with about 2 ways. Okay? I can show you about 2 ways for this. We can use the graph to show it, and we can as well use even the graph is a simpler method, very simpler method. You know the graph of sine x is a sinusoidal graph, like the anything correct. So cos x is also like that, starting from here and ending here. It's just the opposite of sine x. That is cos x graph. So now, when y equals cos x, wow, the y dx is what? Anyone? Everyone, be noting these things. You can see it, even part of you that are telling us. So, when y is sine x, the y dx is cos x, normally. But when y is cos x, the y dx is minus sine x. This could also be derived from the first principle or from the graph. It's only going to show us that the inverse of the graph of cos x becomes the graph of sine x. Inverse of the graph of cos x, or the derivative, when looking for the slope, it gives us the graph of sine x. That is it. So when y equals cos x, then dy dx is sine x. When y equals cos x, dy dx is sine x. That is another thing. So now, when y equals tan x, you can use one law here. We call it the quotient rule to find the derivative of tan x. And you can as well use the graphical method. But instead of going through that, just know it offhand. When y is tan x, y dx is, anyone here?
Sec square x.
I'm impressed. Sec squared x. That is, when y is tan x, then the y dx will be sec square x. A very quick test, everyone. Y equals 9x squared plus 7x cubed, or plus 9x cubed plus 7x squared plus 9x minus 9 cos x plus 7 tan x. The derivative. Shall I rewrite it for you to see very well? Y equals 9x cubed plus 7x squared plus 9x minus 9 plus x plus 7 times x minus sine x. Let me add some x to it. Let's make it snappy. Some of you do not even need to take your
27x squared
Okay.
plus 4x plus 9 plus 9x plus 7 secant square secant square x
Okay.
minus cos x.
Perfect. Very perfect. But what did you say here? Did you say minus 9 sine x?
No, plus 9 sin x.
I think we had 2 or 3 that said it. You are all correct. That is very good. That's impressive. So, please, I haven't understood this thing. Let me quickly see how we proceed with the standard derivative. Still have more of them. Okay. Question. I didn't hear you. You can just show me by raising your arm if you didn't understand. What the reaction? Miss Gracious doesn't get it. Who else here, please? I didn't understand it. Okay. Okay. I'll treat it as the two of you. Let's concentrate on you. I wish you the best. We have been talking about the derivative of normal polynomials, normal functions like this. And when we got to trigonometric functions, we said when y equals sine x, they are given basically that y is equal to sine x, find dy dx. You are just going to write it out that dy dx is equal to cos x. What I'm saying is that I can use the graphical method. This is the graph of sine x. I didn't want to waste time on that before. This is the graph of sine x. It's a sinusoidal graph. So looking for the tangent here, the tangent of this one here now, the tangent at the first point comes. I'm going to have a graph that is like this. And this is the graph of cos x. And that cos x is giving me exactly the tangent of this sine x. So this is the form of the tangent of sine x. And it is exactly the graph of cosine x. So I say dy dx or dx of sine x is giving me cosine x. So when y is equal to sine x, if you are not interested in proving the law, you can use the first principle as well. I don't want to use the first principle today at all. If you are not interested in proving all that, then cram it as simple as saying y equals sine x, then dy dx is cos x. I can write it this way: sine x prime is equal to cos x. I can write it in this way: d dx of sine x is equal to cosine x. Am I making sense, guys? It's Gracious or Mrs. Mr. Emily, or have you gotten some things about it? Perhaps when we keep having examples, when we start having examples, maybe we'll be getting it better. So let's proceed. When y equals tan x, we have the y dx to be equal to sec square x. So now tell me, when y equals cotangent x, or shall I, let me take it from sec x. When y equals sec x, now who is going to tell me the y dx? When y equals sec x is what? I mean, Joy. Back if you know. Anyone? All right, nobody for it. So when y equals sec x, then the y dx equals minus sec x tan x. It's as simple as that. Everyone, are we moving together? Please let me be knowing if we are together. So when y equals sec x, then the y dx is equal to minus sec x and x. It's a simple analogy. So now for y equals cot x, don't forget the trigonometric ratios. You are using them. When you know tan x equals to sine x over cosine x, sec x is equal to 1 over cosine x. Cosec x is equal to 1 over sine x. And cotangent x is equal to 1 over tan x. Please put it somewhere because we will use it in everything we are doing now. Okay. Can you see the board? I'll change the marker now. Black marker. Are we together, everyone? Did you get what I wrote here? We need the information. We use it to solve some things.
I can't see the last.
We said cot x, that is cotangent. Cot x is equal to 1 over tan x. Cot x is equal to 1 over tan x. Cot x equals 1 over tan x. So, but sorry for that. Is it clear now?
Yes, which one is before the last one?
Cosec x equals 1 over sine x. You should know it before. It's the trigonometric ratios. Tan x equals to sine x over cos x. Then sec x equals 1 over cosine x. Cosec x is equal to 1 over sine x. And cotangent x is equal to 1 over tan x. So tan x is equal to the ratio of sine x to cos x. Sec x is the reciprocal of cos x. Cosec x is the reciprocal of sine x. Cotangent x is the reciprocal of tan x. We have this one is related to the unit circle. This is the unit circle. Everything done here is related to the unit circle. They used the unit circle to derive sine x, cotangent x, all those things. Instead of using the unit circle, they use the unit circle here. So instead of using the unit circle, we can as well use the hyperbola, and that is where we'll be having hyperbolic functions. That is where we'll be having what? Hyperbolic functions. In hyperbolic functions, sine hx, that is hyperbolic sine x. This is cyclic sine x. Cyclic sine x. Sine x is equal to what? Opposite over hypotenuse. But hyperbolic sine x is equal to e raised to the power of x minus e raised to the power of minus x divided by 2, where e is known as the common exponential. That is the Euler constant. This is hyperbolic. Wait, all these things are not in the material. Please forget it. Sorry for that. I think they only treated the unit circle in the material. Sorry for that. I'm sorry, I went too far. So let's continue now. When y is equal to cotangent x, please let me know. Are we still together? Are we still together?
We are.
All right. All right. So when y equals to cot x, that is the cotangent x, then the y dx is equal to minus cosec x, minus cosec squared x, minus cosec squared x, minus cosec squared x. when y equal to cot x, then the y dx is minus cosine squared x. One more. Excuse me for a minute, please. No. Are we together? Sorry, I'm back. I had to take a. Are we together again? Are you hearing me? Hello?
Yes, we can.
So now we've done when y equals, we still have more. Please, you have to open this thing that we call our smartness, everyone. You need to put your attention. We said when y equals sine x, then the y dx equals cosine x. When y equals cosine x, then the y dx equals minus sine x. When y equals tan x, the y dx equals sec squared x. And when y equals sec x itself, the y dx is minus sec x tan x. When y equals cot x, the y dx is minus cosec squared x. So when y equals cosec x itself, then the y dx is equal to minus cosec x tan x. Minus cosec x tan x. That is the y dx in this case. So when y equals log x to base a, everyone, I need you to be attentive. That is log x to any base. Then the y dx is going to be 1 over x times log a. That is x times log a. Are we together? Don't worry, I can as well prove this out for you. We are only going to waste time on it. That's why. And when y equals this e raised to power x is the same as writing log x base e. It is called the exponent of x. Exponent of x. So when y equals e raised to power x, then the y, please don't give up. I can see somebody is already hissing in his or her mind. Don't give up. You have to know these things because I think some of you have seen the TMA questions. You saw that it came out. I can assure you, if you could memorize these things, you could go with our lectures and follow the right steps, practice. I assure you will get nothing less than an A or a B in your maths. I can assure you that. You just have to practice diligently, know the right thing to know. When you know what you are supposed to know, I don't think the exam is going to be an issue for you. Know what you are supposed to know. E is called the Euler constant. It was developed by Sir John Euler or something. Euler. It is the Euler constant. The value is 2.7108. Something. That is E. E. So now log to base E gives the natural logarithm. We call it lim. We call it the Napierian logarithm. The Napierian logarithm. Logarithm was actually invented or discovered or postulated by John Napier. So we call it Napierian logarithm. So when y equals lim x, This you will encounter all these in questions. When y equals ln x, those of you that have taken your TMS yourself, you can say living witnesses. Am I right or wrong, everyone? Those of you that took your own TMS by yourself, didn't you encounter solves like
Yes,
this?
I saw something like this.
Exactly. So if you are about this now, you won't be able to do them. So, but once you please just try to know them offhand, even if it's just to cram them for the exam, and after the exam, forget it. Just try to know them. When y equals ln x, then the y dx is equal to 1 over x. Finish. I'll stop here. I still have the inverse function. When y equals to x, x sine x, then the y dx is going to be what? 1 over square root of 1 over square root of a squared minus x squared. If it is minus x squared. So also we have the hyperbolic function, but all those ones are useless in this instance or at this moment. That is why I'm not including them. So they are known as the standard derivatives, and they also have their ways of getting them as well. But knowing this offhand provides a space for you. So I'm going to read everything repeatedly now. 1. When y equals sine x, then the y dx equals cos x. When y equals cosine x, then the y dx equals minus sine x. When y equals tan x, then the y dx is sec squared x. When y equals sec x, you can see this is more of geometric derivatives or differentiation. Then the y dx is equal to sec minus sec x tan x. If y equals to cot x, that is the cotangent of x, that is 1 over tan x. Then the y dx is minus cosec squared x. When y equals cosec x, the y dx is minus cosec x tan x. Hey, that was a mistake. It is supposed to be cot x. Minus cosec x cot x. Thank God I saw it back. Else I would have misled some people. So when y equals cosec x, then the y dx is minus cosec x cotangent x. And when y equals log x base a, then the y dx is 1 over x times log a. 1 over x times log a. That is what is happening here too. So lim, we said lim x is log x base e. So we are having 1 over x times log e, but base e is still the thing here. So log e base e gives what? 1. Because log anything to that thing, to the base of that thing gives 1. Don't worry, don't disturb yourself. Lots of probability. Just forget it now. Know the standard derivatives. When y equals e raised to power x, the y dx is the same thing. We can prove this using the series method, using the differential method, and using the loss, the power method, and using the loss of what we do. If you are interested, later. So, and when y equals ln x, that is the natural logarithm of x or the Napierian logarithm of x, the y dx equals 1 over x. Are we good to go? Just a pausing. As I don't talk. Okay. So I don't know if some of you have memorized this. I don't know if you write them down. I actually took my time to write all this now. So we are going to use them in our next examples. That is it. We are using them in the next examples straight away. So you should have them written at the back of your mind or at the back of your notebook at the moment. Please, I'm waiting for you. I'm waiting for you. Because we need them now, and I will hate the situation whereby I will ask, what is the derivative of sec x, and nobody will be able to answer me. I really feel bad. So if you are going to put it down, go ahead. If you are screenshotting it, go ahead. I just want people to provide answers for me when we are working with them. I just be teaching and you guys will not be with me. So bad. It's time. It's very precious. Shall we go ahead? Shall we wrap it up? All right,
We
then.
can move.
Okay. Now, all the standard derivatives. We can now enter the rules. We can enter the mute your mics. Mute your mics. So we can enter the rules of simple calculus. You people should mute your mics. Mute your mind. This will be wasting our time. So now let's take the product rule on. Who's this person now?
David,
Mr.
mute your mic.
Abi, you know. You don't have to. Just leave the boss. Let him embarrass himself. Okay, the product rule now. They are given. We know what a product is, right? A product is an operation that involves the combination of two variables or data that are linked together by multiplication. So U times V becomes UV. So if I have y equals x squared sine x, that means x squared times sine x. Am I making sense? So I can say y is a product of x squared and sine x. I can say y is equal to x squared ln x. Then I can say y is a product of x squared and ln x. Where my u would be x squared, my v would be ln x or sine x. I can as well say when y equals x minus 3 times x minus 2. Then I can say my u is x minus 3 and my v is x minus 2. Are we able to evaluate this thing now? Can you tell me where your u is now and your v is now? Shall we go ahead for this?
Yes.
Okay. So let me take the first. Okay, the last thing here will be better. When y equals u times v, the product rule states that when the function is a product of two functions, when a function is the product of two functions, then the derivative of that function y dx is going to be the product of the first function and the derivative of the second function. The product of the first function and the derivative of the second function, that is u dv, u dv dx, plus the product of the second function and the derivative of the first function, that is v u dx. As simple as this. dy dx equals to v du dx plus u dv dx, or u dv dx plus v dv dx. It is associative, or it is commutative rather. Everyone, if y is given to be a product of two variables, then put them in u and v, and dy dx will be equal to du dx plus dy dx will be equal to u v du dx plus u dv dx. V du dx plus u dv dx. Am I making sense? Am I making sense? I don't want to leave anyone behind before you start taking us back. Am I making sense, everyone? So you can put the formula at the back of your mind. V du dx plus u dx. Keep the formula somewhere in your mind. And then let's continue. That's when y equals 3x squared plus 2 times 2x minus 1. Find dy dx. I mean, there are two ways to solve this thing. Can you give us one idea? The first idea, instead of using the product rule, is there anything we could do? Okay, don't let me call him. Anyone?
Okay.
What do you think we can do? Instead of using the product rule, okay, we have forgotten the product rule. I don't know how to use it. What can I do to this?
You can find the
Anyone?
derivative of
What did you say?
you can find the derivative of 3x plus 2 and 2x minus 2.
You can't find it differently. We have to use the formula if it is still in this form. If it is in this form, you must use the formula. Don't find the derivative of this one and multiply it by, you say the derivative of 3x squared plus 2, that is 6x, right? And you go and multiply it by 2, which is the derivative of this. No, that is why the rule is there. It gives you nothing. You get it very wrongly or very wrong. So the first thing you could resort to is that open your bracket. By opening your bracket, you are going to have 6x cubed, 6x cubed minus 3x squared plus 4x, so minus 2. So you can go and differentiate down straight away. That is the first way. I think some people are talking me now. But instead of doing that, you can as well use the product rule. We said y is going to be equal to u. So my u is what? Everyone here. I want us to work together. What is my u? 3x squared plus
Plus
2.
2.
And my b is 2x minus 1. I have to find the v dx and find the u dx because it is involved in the formula. So the v dx is equal to 2 times 3. That is 6x raised to power 2 minus 1 is 1. And the derivative of the constant is 0. So the u dx, sorry, the u dx is 0. 6x, right? So now the v dx is equal to the derivative of 2x is what? 2. Don't stress yourself. 2 and minus 1 is 0. Now use the product rule. Product rule says dy dx equals to v du dx plus u du dx. v du dx plus u du dx. What is v? V is, you can go and find it out for where you put it, 2x minus 1 times what du dx. Please mute your mind, this one now. Now you are disturbing everyone's peace, please. So 2x minus 1 times du dx is 6x. That's it again. Plus u is what? 3x squared plus 2. So 3x squared plus 2 times the v dx is brought into what? Times 2. So we can say this gives us 2x times 6x. That is 12x squared minus 6x plus 2 times 3x squared, 6x squared plus 4. We can do the right thing here now. 12x squared plus 6x squared gives 18x squared minus 6x plus 4 is the derivative of function. So the idea equals 18x squared minus 6x plus 4. Are we making sense? Who is this person? This person is making me really get into action. Please, any question on this? Any question on the product rule? Any question, guys?
Okay, I want to ask if one of the variable has a power, is there a way we can calculate it directly without using the product rule?
If one of them is having power, that means it is already a function of another function. We are going to use the quotient rule in that case. We are going to use the quotient rule. So we will treat composite function rule, that is function of a function. We call it the chain rule. So we'll treat chain rule too. Don't worry. It's not quotient rule, that was a mistake. we will treat chain rule too, don't worry. So you are going to use chain rule now. For all these things, I'll teach you the tricks. Instead of you using chain rules or any other rules, I'll just do everything with my brain. So I'll just teach you these tricks later. There's no trick for product. You can use your brain to use the formula and the likes. There's no trick for it. This is the way you do it. You can do everything in your brain if you're so smart to do it. But if not, just take your pen and print out. But generally, I'll just teach you this the trick about formula and so many of them. Shall we go ahead, everyone? David, I want you to mute your mind. Is there any way to just remove this phone? Please do now. That thing is just disturbing my phone. What is it not here? The battery is one battery down. Okay, guys. I think we should take one more example on how they put on food. I won't do anything. Why? Because
Tunde, please mute your mic.
y equals 3x squared sine x. Are we together? 3x squared sine x. We can use the product rule because it's the product of 3x squared and sine x. So what is g? What is b? One thing you might not know is that you can be anything in product rule and b can be anything. Not so in other rules. So when in product rule, u can be anything, b can be anything. So I'm taking my u to be 3x squared. I'm taking my b to the sine x. So I have to find the derivatives of the two. The u dx is what? Tell me straight away, anyone. The u dx 6x, thank you. The v dx is what? Naomi, I would like you to tell me. V dx. V dx, why v is sine x? The v dx is what?
Cos S.
So the v dx is cosine x. We can use the formula now that the y dx equals b du dx plus u dv dx. Because of the commutative property, it can also be written as u dv dx plus b dv, because the operand here is plus, or the operator here is plus. So v is what? Sine x. We do the needful. Sine x times du dx is what? 3x squared. Plus u is what? 3x. Sorry. The u dx is 6x. U dx is 6x. So u is what? 3x squared times the v dx is what? Cosine x. So I have 6x sine x plus 3x squared cosine x. You can say 3 is common and x is common. So bring 3x out. You have 2 sine x plus x cos x. This can even be a question in your TMA. I think there was a question similar to this. I just formed it somehow. There's a question similar to this. I think I encountered some questions. So everyone, did you understand what we just did? I don't get it. Please speak out. Don't hesitate. Don't be shy. I didn't understand it. Let me see. I did understand it. Let's hear. I understood it. Nobody. Political apathy.
You did
Stephenson. I didn't understand it. Is your network okay now? Can you hear me now? Stephen, Can you
Yes,
hear me
I can
now?
hear you.
Yes, I can hear you.
Yes, I
Okay.
can hear you.
Okay. So y equals 3x squared sine x. Y equals 3x squared sine x. So we have to divide it into two, split it into two. This is a product of 3x squared and sine x. 3x squared is another function on its own. Say y equals to 3x squared. And sine x is another function on its own. Y equals to sine x. You can see there are two independent. That's 3x squared. You multiply it by the differentiation, the derivative of sine x, you get 0. Don't use that rule, it's useless. You have to follow the product rule. It's a formula for product rule. Very simple. It's time. Unless I would have derived it. So u equals 3x squared and v equals sine x. So find the u dx. You would have 2 times 3, 6. X raised to power 2 minus 1. That is 6x. The v dx gives normal standard derivative. Sine x, derivative of sine x is cosine x. So dy dx is equal to v du dx plus u du dx. Write it out using the product rule. Using the product rule. So, what's your question, Emily, before I go too far? Speak out, please. Emily. So, v is what? V is sine x, and here it is. The u dx is 6x, here it is. Plus, u is 3x squared, here it is. And the v dx is cosine x, here it is. So I believe you can compute all of that things yourself. 6x times sine x gives 6x sine x. Plus 3x squared times cosine x gives 3x squared cosine x. So 3x is common here and here. So, and you can as well leave your final answer as this. It depends on your mind. So are we clear about the product rule now? Nobody will reply. That's what I hate. Please, all this hesitation is wasting my own time. How will I move forward? Or not? Please, you can try this on your own, not in this class. Y equals 5x cubed ln x. Y equals 2x. Y equals ln x sine x. Y equals cosec x times x. So you can try this. Find the y dx for this. If you could do this, or you don't become boss. Just use the product rule to do it. Number 1, y equals to 5x cubed ln x. 2, y equals ln x times sine x. 3, y equals cosec x times tan x. Please, you can do it and drop it in the group. Drop it in the group after trying it. I can see many of you now, they will even attempt any question you want to hear there. That's why I don't want to be stressing myself too much. So it depends on your own. Everything is just. So, shall we move ahead? I think we should. So, there is one thing we call quotient and remainder. Quotient, remainder, dividend. When y equals a function over another function, like function u over function p, then this place now, you must not misplace anything. U is equal to the numerator and v is the denominator function. Once you miscarry there, once you mistake either of them, then everything will be wrong for you in the problem. So what do? Your numerator is u, your denominator is v. In this case, then the very derivative of y, which is dy dx, will be given as v du dx minus u dv dx. It can never be u dv dx minus v dx. Minus is not commutative. There is no commutative property. So v du dx minus u dv dx over v squared. That is the formula for dy dx when y equals u over v. Am I making sense?
Yeah.
Okay. So now we're going to use this to solve something. Your u is the numerator, v is the denominator. Don't take it otherwise. You have to look for the u dx, and yes, while looking for the v dx. So I'm given the function y equals x minus 3 over x squared plus 1. We go. U is what? Numerator, that is x minus 3. V is what? Denominator, that is x squared plus 1. Now, the u dx is equal to 1 here, right? And the v dx is equal to 2x. That is x squared plus 1. So 2 times this, that is 2x. Raised to power 2 minus 1, that is 2x raised to power 1. And that is 2x. So now we've gotten u, we've gotten v, the u and the v. So the y dx is equal to v du dx. What is v? X squared plus 1. X squared plus 1 times du dx is what? 1 times 1 minus u dv dx. What is u? U is x minus 3 times dv dx is 2x all over v squared. That is x squared plus 1 squared. Am I not too fast? Hope I'm not too fast. Are we moving together?
You
Are you
are.
lost? I'm too fast. Okay. Please listen again. The u dx is 1 here. So here it is. The v dx is 2x. By practicing differentiation well, better, you get to know all this. So just take problems and solve them. Solve problems. Don't say because you entered class, you know nothing in the exam, but you don't solve problems. So tell those people here, beg them to give you their TMA screenshots. TMA screenshots. Practice there. All those all those TMA questions might even many of them should be examples from the material. Yeah, it happens that case. That way. I don't know though, but you can try to look at the material. You will definitely see many of them from the material. So dy dx is equal to b du dx. What is b? That is x squared plus 1. So x squared plus 1 times du dx, which is 1. So times 1 minus u dv dx. What is u? X minus 3 times dv dx, which is 2x, divided by b squared. That is x plus 1 squared. We still have a long way to go. I think we'll stop at quotient rule. So we're still doing integration, and integration has its own rules as well. So many rules. So dy dx is equal to x squared plus 1 minus 2x squared plus 6x divided by x squared plus 1 squared. So this is going to give us x squared minus 2x squared. That is minus x squared plus 6x plus 1 divided by x squared plus 1 squared. This is going to be having imaginary roots at the end of the day. I mean the numerator. So we found the derivative of y. That is the derivative of y. Are we together, everyone?
The board is not showing very well.
You can see, but once you understand the step, then that's the best thing. That's the most important thing. Let's see, x squared plus 1 squared. Just manage it, please. Yes, thanks for understanding. Okay. Any question so far? Any question from anyone? Any question? Okay, let's treat it as no question. Everyone, differentiate y equals tan x. I told you to write some things at the back of your mind or your book earlier. So differentiate y equals tan x. Don't carry the standard derivative. We know that dy dx is going to be equal to sec square x. But forget that thing. How did they get the sec square x? Use the quotient rule to do that. Anyone? Is there anyone that's going to give it a try? Be responding to your law.
I know you have to say
I said differentiate tan x. And don't write, we know it's a standard derivative, standard function. So there will be a derivative for it straight away, which is sec squared x. So where is that sec squared x gotten from? That is what I'm asking. Differentiate tan x. Use the quotient rule. What do I mean by that? I mean tan x is always equal to sine x over cos x. Tan x is equal to what? Sine x over cos x. So use the quotient rule that u is sine x and v is cosine x. Then what is your answer? Did anyone understand my word here? Please let me know if you understand it. I'm getting really tired.
you mean to work it out and for making the group of it.
Hmm?
You say we mean that we should work it out, like we should prove that an x is equal to sin x over cos x.
Now, no, tan x equals to sine x over cos x. Then use the quotient rule to find the derivative of sine x over cos x. Use the quotient rule to find the derivative of sine x over cos x.
Okay.
Use the quotient rule to find the derivative of sine x over cos x. I'm really getting tired. I can leave anytime. Anyone with the answer? What did you arrive at once you put it? Let's know what you arrived at.
Okay, I got cos square x plus sine square x over cos square x.
Oh yes, you haven't finished the working. You simplify mathematics until you can no longer simplify further. There are three identities in trigonometry. We call them the trigonometric identities. In trigonometric units for unit circle, basic trigonometries. The first one is sine squared x plus cos squared x equals to 1. What do I mean by that? Anywhere you see sine square x that is being added to cos square x, just represent it by 1. So what do you do now? That the top, the numerator there, oh yeah, represent it by 1. Have you done that?
Yes.
So you are left with 1 over what?
Cos square x.
So there is another trigonometric ratio that I just taught you now, that sec theta equals to 1 over cos theta. So secant theta is equal to 1 over cosine theta. So therefore, secant squared theta is equal to 1 over cosine squared theta. So represent 1 over cos squared theta by sec squared theta. Done? my sec square x there now?
The final answer is 1 over secant square x.
1 over cos theta. No. I'm using theta to represent x. They are the same thing. Don't let me confuse you. They are the same thing. Theta and x are the same thing in this instance.
Okay,
Are you
so
getting it?
secant squared, Abi.
So you have 1 over cos squared x, right? 1
Yes.
over cos squared x. So that 1 over cos squared x now, we said it is equal to what? Sec squared x.
Okay.
As we know that 1 over sine square x is equal to cosec square x. So 1 over cos squared x is equal to secant squared x.
Okay, not
So
1
you have
over.
sec squared x. Do you have sec squared x as your final answer now?
But it's not the division, just normal.
The division, no, 1 over
Okay,
cos
okay.
squared x will always give you sec squared x. I said sec x is the reciprocal of cos x. So you have the reciprocal of cos squared x now. Definitely it should be equal to sec squared x.
Okay.
So that sec squared x is the final answer. Don't forget that what you differentiated was tan x. That is why the derivative of tan x is equal to sec squared x. You just proved it yourself now. You don't seem
Okay.
to get me.
Yeah, I
So
understand.
that's it. We are using the quotient rule to do that. Please, Emily, what's your question? Did you solve the work? Emily, you're raising your arm, please.
Yeah, that was a mistake. Sorry.
Okay. Any question from anyone? I'm taking my leave now. Any question from anyone? Did we all understand the thing presented today? No, it's finished.